This is Unit 2, Matter, Lesson 3, Particle Diagrams. How are different types of matter represented in particle diagrams? The objectives of this video: I can differentiate between different types of particle diagrams, and I can construct particle diagrams for pure substances and mixtures. So quick do now review. So particle diagrams show how the forms of matter look in a simple diagram form. We have different types of particle diagrams. Elements in monoatomic form will show single atoms not bonded to each other. So I could represent that as a open circle. This is just a single atom, not bonded to anything else. So they are just separated by themselves. Elements that are diatomic will show two of the same elements bonded together. So a different element I'm going to represent as a filled in circle, two circles connected together. They should be touching each other. So these are diatomic elements, the same elements bonded together. Compounds show two or more different elements chemically bonded together in a definite whole number ratio. So if I were to represent carbon as an open circle and oxygen as a closed circle, this would represent carbon monoxide. Two different elements bonded together, and they'll always be in that same 1-to-1 ratio. One carbon, one oxygen. I could also draw carbon and oxygen backwards. That's still the same thing. Water, I would also do the same thing, H2O. This would be one oxygen and then two hydrogens. And they should be touching. So my finger doesn't quite make them touch. Make sure yours and your diagrams touch. H2O, I've got oxygen and then two H's. I can draw them in any orientation as long as I'm representing the different elements. Two hydrogens chemically bonded together with one oxygen. A mixture is going to show a combination of elements, compounds, or both in no fixed ratio and not bonded together. So a mixture of an element and a compound. Let's say I have a diatomic element mixed with water. So I'm going to draw my water again. And then they're going to not be in any fixed ratio. So it doesn't matter how many of each. I'm going to draw a lot more waters just to show I have more. And then just a couple of elements mixed in. That's not a fixed ratio. So, example, you might be asked to classify as an element, compound, or a mixture. So this here, I have a bunch of single circles filled in. They're all the same element, and they're not bonded together. So this would represent a monatomic element. A second example classifies an element, compound, or mixture. Now I have open circles and closed circles mixed together. Each open circle represents one type of element, and the closed circles represent a different type of element. And because I've got two different elements mixed together, this would represent a mixture of two elements. A mixture of two elements. And because they are single by themselves, they would be represented. They are monatomic elements. Just one. So check your understanding. Label each of the particle diagrams. So this lesson's objectives: I can differentiate between different types of particle diagrams, and I can construct particle diagrams for pure substances and mixtures.